Hi everybody, it's Dr. Jones here, the chemistry tutor, and today we're going to be calculating molarities. So let's get straight on with the first question. Calculate the molarity M of a solution prepared by dissolving 9.8 moles of solid NaOH, that's a chemical formula for sodium hydroxide, and enough water to make 3.62 litres of solution. Now what we're going to do is we're going to break this question down into its component parts and answer one by one. Now to begin with, we have to find out, we're asked to calculate the molarity M. So we need to know what is molarity. Now molarity is an amount of something, an amount per 1 litre. So we've got the number of moles, the amount of moles in 1 litre. So what do we actually have in this question? Well, we know an amount of moles. We have 9.8 moles of the compound sodium hydroxide in 3.62 litres. So we know we've got 9.8 moles in 3.62 litres. But to calculate molarity, what we need to know is the amount of moles in 1 litre. So if we perform the calculation, 9.8 divided by 3.62, it gives us the amount of moles in 1 litre. Sorry, my handwriting is atrocious. In 1 litre. So we've got the amount of moles in 1 litre. So we've got 2.7 moles in 1 litre, or we say 2.7 molar. So the answer is 2.7 molar. Okay, I hope you all understood that. If you didn't, please leave a comment down below and I'll see if I can get back to you as soon as possible. Okay, on to the next question. Now we have to calculate, Gordon Bennett. We have to calculate the molarity, again it's calculate the molarity of a solution prepared by dissolving 850 grams of sodium hydroxide in enough water to make 5.2 litres of solution. Now in this question we're not given the amount of moles, we're given the amount in grams. So what we're going to have to do is we're going to have to convert the amount of grams into the amount of moles. Now how do we go about converting grams into moles? Well, first of all we have to have a look at our periodic table, and we've got to look at the elements that constitute sodium hydroxide. So we've got sodium, oxygen and hydrogen. Now the number at the bottom of each of these elements here, it's variably known as the relative atomic mass or the atomic weight or the average atomic weight. All of these, it's the same thing. Some teachers like to use one of these, but they're actually the same thing. They're also known as, I think, the mass number. One of these for you. But they all mean the same thing. Now these atomic masses, I'm going to call them atomic masses. Now the molecular mass in grams is calculated by adding all the relative atomic masses together. So all the relative atomic masses together will give you the atomic mass. So let me show you what I mean. So here we have sodium hydroxide. So we have 1 atom of sodium, 1 atom of oxygen and 1 atom of hydrogen. That's 23 grams from over here, 16 grams from here and 1 gram from here. Now the total is 40 grams. So the molecular mass of sodium hydroxide is 40 grams. Now the molecular mass also equals the amount that 1 mole would equal. So we say 1 mole of sodium hydroxide equals 40 grams. 40 grams. So how do we use this piece of information in our original question? So we had 850 grams in 5.2 litres. So 1 mole of sodium hydroxide, we know it equals 40 grams. Now if we know 1 mole of sodium hydroxide equals 40 grams, and we have 850 grams, how many moles do we have? Well, the answer is it's going to be approximately 20 moles. Now if we do this calculation here, if we take 850 grams and we divide it by 40 grams per mole, it will give us the amount of moles we've got. So we knew we had 850 grams in 5.2 litres. And what we've done is we've converted the grams into moles. So now we know we've got 21.3 moles in 5.2 litres. But if you look at back here, molarity is the amount of moles per litre, the amount of moles in 1 litre, in 1 litre. So what we need to do is, if we've got 21.3 moles in 5.2 litres, to find out how much we've got in 1 litre, we take 21.3 moles and we divide it by 5.2 litres. Now this gives us 4.1 moles in 1 litre. Sorry, my handwriting is really rubbish with this pen on the computer. And instead of saying 4.1 moles per litre, we say 4.1 molar. So the answer is 4.1 molar. Now if you've got any problems with this question, please leave a comment below. If you've got any problems that don't relate to this question, also please leave a comment below and I'll try and get back to you. I'd like to thank Tyler DeWitt. I've actually used his questions here. I'll actually put a link in the description to his original video. It's absolutely superb, it's absolutely excellent. I just wanted to answer these questions in my own way. Now I've also answered a number of other molarity questions. I'm going to leave those in the description bar below and a link at the end of the video if you'd like to go and have a look. Now one of them is an extremely hard molar question, and you can always try that. It's like a lab-based question to see how it goes. And I would like to thank you for watching. Have a great day.